And then getting back to this problem here, again, this problem is very simple problem. We have solved block on slope, but here it is a curved surface. But you should not worry about this. This surface is not a very smooth surface. It is characterized by mu s value 0.25. And in case of force P is not there, this would be accelerating down on this. So you would use mu k. But the problem here is you are asked to find out, determine the range of value of P for which equilibrium of the block is maintained. So that is
Excuse me, sir.
Yeah.
Sir, Priyansh here. Sir, I actually had this question and I have a doubt. Sir,
Yeah.
will P have an angle with the slope, sir? Because I couldn't understand. It was on a curve, so I wanted to know whether P has an angle with the
No, no.
body it is on.
Yeah. Look at this. It's very clear diagram here. You have this force P is horizontal, right? It is on a horizontal. So if this block is there, which has got a bottom surface, curved surface matching with this curved surface, right? But the application of force is horizontal P, and the weight of this block is 1000 Newton down. So now it is very clear, if I extend this normal here, this line, I would have, in absence of P, this block is sliding down. In presence of P, this block can be prevented sliding down. By increasing value of P, I can make this block moving up. So these are the possible cases, right? I could say that in absence of P, this is not going to stay there, maintaining this 30-degree orientation of the normal to the block to the vertical cannot be maintained. Why? It's because you see that mu s value is given this. So what is your friction angle? Phi s will be tan inverse of 0.25. That would be 14.04 degrees, which is lesser than that of this 30-degree angle, right? So if I draw a slope here for this, it is all at that instant you are working. Block is not on the slope, but for this instant, this block is on this slope of 30 degrees. That's what you should consider, right? So
Sir, so
this
do
is
we have to take an additional angle alpha for P?
why P is given here horizontal direction. Why do you have to take an angle or additional angle here? See, this is very clear. It's horizontal, it's vertical. So you should take as it is given.
Okay, sir.
So here at this instant shown, that is the crux that you should understand. We have solved the problem of block on slope, but now it is not a slope, it is a curved surface. So the slope on a curved surface will vary at every point according to this dimension. So this angle 30 degrees is now dictating the slope angle 30. If this angle 45 degrees is oriented, then the slope is 45 degrees. So that is the relation here that we have. Right. So for the given instant, when you want to maintain the equilibrium, what would be the range of value of P? That is asked. So when it is asked range of value of P, you should understand in absence of P, this cannot stay there. The 30-degree cannot be maintained. It will be sliding, accelerating down. To prevent that, you have to apply force P. So when you apply force P, then the free body diagram is different. If you are increasing the value of P, then this block tendency can just be reversed and it can move up, and then the friction direction is different. So you would get two values. So that is what is asked in this, and it's very simple and straightforward, and you would solve that. If you consider this is our first case, and the free body diagram here is just case 1, just prevent block sliding down. What is the value of P required? So for that, I can just have my free body diagram in this. So what would be my free body diagram? At this point, contact point, I will have my normal. And say this is N. And already this weight is acting down given here, P is given here. And I would have the tendency of this block is just to prevent it, means it is sliding down. The tendency is to come down. So friction force would be in this direction. And that would be of 0.25, 0.25 N. And we have seen that now in this free body diagram, I have force P, weight, and this two components. If I combine these two, we will have an advantage. That's what we have seen. If I combine these two, that would give me, if I combine these two, that would give me an advantage, right? So what is that? I would have this. So this angle is my phi s, whereas this angle, this outer angle is 30 degrees. So what would be this angle? What would be this angle to the vertical? This angle, this angle. That angle is 30 minus phi s. This angle is 30 minus phi s. So if we have this clarity, I can apply Lamy's theorem now comfortably, and I would draw my equivalent diagram, bringing all these four styles together. So P is horizontal. Just let me put this is P. This is my point, a concurrent point, and weight is acting down vertical. So this is weight, 1000 Newton. And then now combined normal and friction force is R, and that R inclination to the vertical. This is vertical and this is the direction of R. R is not vertical. This is vertical line. So there is an inclination. So that inclination to the vertical is 30 degrees minus this phi s. Phi s is what is only 14.04, right? So this is that angle. So I would have here R value to the vertical with this angle 30 minus phi s. So you got phi s is 14.04 degrees. So what is this angle going to be? It is 15 point, this angle here would be 15.96 degrees. So if I have this is very straightforward. I can find what is the value of P for this case by applying Lamy's theorem. So when I do that, P by sine of angle included by other two vector, so sine 180 minus 15.96 degrees. So 180 minus 15.96 degrees, and that will be equal to 1000 divided by angle included by other two vector P and R. It is 90 plus this. So 90 plus this is 105.96 degrees. 105 point sine 105.96 degrees. So this solves for P straight away. So P value would be 1000 into sine of angle 180 minus this would be 164.04 degrees divided by sine 105.96 degrees. So solving this, I get 286 Newton. 286 Newton. So if I apply here in this configuration given P of 286 Newton, this block is just being prevented sliding down. If value of P is less than 286 Newton, 280 Newton also, this would be sliding. So this is the minimum value or the lower range of my value of P. So now to get an upper range value, the same value magnitude, if I keep increasing from 286 onwards, at one point you would see that this block will have a tendency to move up. So in such case, what you have to do? You should draw again a free body diagram. So let us just draw the free body diagram for that, and that diagram will be this. So copy this once again and take this. Take this diagram, and in this once again let us draw a free body diagram for consistent to the second case. So what is the free body diagram? Of course, this weight acting down here 1000 Newton and P, and I would have now my normal here N, and this friction force would have a tendency opposite to this expected motion. So that would be here. So that is 0.25 times N. And if I combine these two, this is my reaction R, and that would have here the angle phi s. This is phi s, and already this is now normal, and that would have to this angle 30 degrees. So now the direction of R to the vertical is 30 plus phi s, right? So that is all. So this is case 2. just to make the block to move up. So this is case 2. P for the block to move up, just to move up, just to move up. So if that is so, I would redraw my free body diagram again as a concurrent system. So concurrent point is tail of all the vectors. So 1000 Newton, P is horizontal and 1000 Newton is vertical weight. And my R now to the vertical is 30 plus 5s. So it is 44.04 degrees. This is R, and this angle is 44.04 degrees. So I would be solving for P. That's very straightforward. So I can write P by sine of angle included by this, that is sine 180 minus 44.04 degrees. That's equal to 1000 divided by sine of angle included by P and R. So sine 90 plus that, that's 134.04 degrees. So this solves for P, and P value will be 1000 into sine 180 minus 44.04 is what is that angle? That is 135.96. This is 135.96 degrees divided by sine 134.04 degrees, right? So now by solving this, I get P value is 967 Newton. 967 Newton. So now what does that you understand? The question asks, what is the range of value of P to maintain the given configuration under equilibrium? So for that, the range of value of P value should be less than or equal to 967 Newton, or it should be greater than or equal to 286 Newton. Required for maintaining the equilibrium. Right? So this is how you can solve, and this is very simple. I hope you all would have solved correctly. So you get 5 marks each for both the cases.